Okay, I got a little carried away as usual in my quest to find the best 2000 watt 12 volt inverter and ended up with quite a few in my lineup. I have the most popular inverter on Amazon and the cheapest pure sine wave inverter you can get on Amazon, all the way up to these industrial beasts. I am running a gauntlet of tests to find out which one is the best and which ones can do the most important thing for your particular application. Welcome back to Projects with Everyday Dave. It's time to do some testing. There's a lot of content in this video, so I've included chapter markers at the bottom so that you can jump to any section. There are chapters for the test setup, the conclusions, and all the other details, as well as a separate chapter for each one of the inverters. So if there's just one you're interested in, you can jump right to it. So let's get started with the test setup. Here's how I ended up with these particular inverters. My original goal was to buy all of them myself so no one could complain about conflict of interest. So I purchased the Renogy since it's by far, the most popular inverter on Amazon. And I bought this MaxPart inverter because it was pretty much the cheapest inverter that I could get that said pure sine wave and 2000 watt, but still had quite a few sales. So this one's fairly popular as well, but it's pretty inexpensive. I bought the Giandel because this one is recommended by other YouTubers. People seem to like it a lot, and I thought I should check it out. These next three here were sent to me by the manufacturers, but I'm doing the same tests on all of them. I'll report all out the same, so I think you should be able to have confidence in the results. I included the new LiTime inverter because they're supplying the power for this testing with their fantastic 560 amp hour battery. It can provide up to 300 amps continuously. Without it, I would need to parallel several batteries together in order to supply the power that these inverters need. So thank you, LiTime, for maximizing my test efficiency. I'll let you know at the end how well it performs. I've tested a lot of BougeRV equipment and I'm usually very happy with the results. So I was happy to let them include their inverter in this test and hopefully it performs really well. These last two are on more of an industrial level and they have transformers in them as opposed to these transformerless inverters that we have over here. So that's part of why they're significantly different in size and they're also way heavier. And this Sungold inverter is 2 kilowatt, just like the rest of these. Then I have this Victron 3 kVA inverter that I'm borrowing from my friend Ed at Off Grid Power Systems. We've been working together on several projects now, and I love to support local small businesses. I'll leave a link to his website below. If you live in or around Ohio and you need an installer for an off-grid system, I can happily recommend Off Grid Power Systems. That's the lineup, and now let's go over the test setup. I'm using this LiTime 560 amp hour battery for all the testing. This thing is a beast. I put it on a skateboard just so that I can move it around. I mean, it's really heavy. I'm protecting the battery with a 250 amp post-attached fuse directly to the battery to protect the system and 2-aught cables from the battery to my distribution and load monitoring board. So let's go over a few details on this board so you know how I'm measuring everything. Okay, I just have a simple power management board set up here. This side connects to the battery. I have my plus and minus cables, and all of the main cables are 2-aught. I have a Victron shunt, so I have power in from the battery and out on the other side of the shunt to the negative bus bar. The shunt is connected to this little display so that I can monitor things real time. The positive for that is connected to the battery terminal side of my on-off switch. This on-off switch will disconnect power to and from the battery, and the fuse is mounted on the battery itself, so I don't have any fuses or breakers on this panel. I do, however, have a small charging circuit, and I'm using a light bulb instead of a resistor to make sure I don't have any short circuits, and it gives me a good visual of when the capacitors are charged. So I'll be able to press this button, the light will come on, and when it dims, I know that the capacitors are charged, then I can turn my switch on. I have the shunt resistor connecting across the poles of the switch. So on the back side, I have one side of the shunt resistor on one side of the switch and the other side of the shunt resistor coming into the other side of the switch. And then this is power to the Victron shunt. So there's 2 extra wires coming to the battery side and 1 wire going to the load side. And that's the way the switch is wired. Here's my special box to replace the charge resistor, and I just use a little light bulb and a button. I 3D printed that. I'll leave a link in the description. You can download that for free. I just used a little light bulb socket and a button. So the way it works is I've connected positive to the hot side of the switch, and negative goes to the load side of the switch. And then I'm just completing the circuit through the light bulb. If I have a short circuit, the light bulb will come on and it won't turn off. If it's wired properly, when I push the button, the light will come on and then dim as the resistors charge, and that will indicate I can turn this whole system on and we'll be good to go. From the switch, the positive goes to the positive bus bar. Now I have my positive and negative bus bars. I have an Anderson connector for my input. I should probably have a fuse on that, but I'm just using a regular charger right now. I could connect my solar charge controller through this Anderson plug. Either way, I should have a breaker in here. Maybe I'll add that later. Then off of these bus bars, I have my cables going to the inverter, and so I can run any inverter I want on this side and any battery I want on that side. I made this simple little device I can plug into the inverter and easily attach the probes of my oscilloscope so that I can measure the sine wave performance both at idle and under a 1400 watt load. I'm measuring the efficiency by running each inverter for 10 minutes at approximately 1400 watts using the heating element in my water heater. I'm measuring the DC input to the inverter with the Victron Smart Shunt, and I'm measuring the AC output with this AC energy meter, and I'm doing it for exactly 10 minutes using this electronic switch. I swapped out this heating element with a 2000 watt heating element so that we can run this equipment right at its max output, and I plan to run it for about 15 minutes on each one. And I don't have a tool that can measure the output at that high of a load without destroying it. And because each one of these units puts out a little bit different voltage, they're really going to be supporting a slightly different load. So that I can give an accurate measurement of the load, I'm going to be measuring the output voltage using my voltmeter, and then I'll measure the current going into the heating element so I can calculate the power that's actually being delivered. And then we'll use the Victron Smart Shunt to measure the DC input power so that we'll have that reference. I'm leaving the covers off of my bus bars so I can take some thermal images of everything so we can see what's getting hot and make sure that it can run 15 minutes at its rated load with no issues. I tried to be clever and swap the heating element without draining all the water, and it would have worked except for I didn't realize that it looped back on itself and I kept hooking this end. And I thought, what in the world am I doing wrong? I can't pull it out. So I ended up draining the whole tank to pull it out. And then I realized if I had just, lifted up a little, I could have pulled it out. Yeah, well, lesson learned. When you're dealing with really high current electronics like this, it's possible that you might forget to torque one of your bolts or have an area that's getting hotter than you anticipate. And it's really helpful to have a thermal camera. And Kiwatts sent me this one for this test activity, which I was looking forward to trying out because it's completely handheld, and all the ones I've used before have to connect to your phone. This one is really handy. I can see in the screen what's going on directly and just point it where I want to. It gives me the high points. And one of the problems I've had with other cameras is if I'm looking at something really hot, like my fireplace, most of them it's way out of range and it can't tell me what it is. But this one has two ranges. I can set it to a high temperature range, and then I can actually see the high temperature points on even my fireplace. So that was a pretty neat feature. I really like that. Anyway, I'll be using this to take some images throughout the testing, and that'll help you see some of the thermal implications. Since Kiwatts sent me this for the test, I'll leave a link below and any discount I can provide for you. Then I'm going to add an additional 1000 watt heater to see how long each inverter can run at about 3000 watts, which would be 50% overload. Beyond just raw power, you may have some equipment that you need to run. So I'm testing to see how well each inverter is able to support startup surge loads. Large induction motors can be particularly difficult to start, especially with transformerless inverters. I've selected a variety of test loads that you're likely to be using. I have a 6 horsepower, 15 amp compressor and a small 10.5 amp pancake compressor. The 5 horsepower shop vac and the 14,300 BTU air conditioner are medium loads that are also commonly used. I do have a dehumidifier here, but I'm only going to test that if a particular inverter won't run the AC unit, because if you can run the AC unit, you can run the dehumidifier. The biggest load of them all is the 1.5 horsepower dust collector. It has a very large motor and it has to spin up a very large fan. It takes a tremendous amount of startup current to do that. I don't expect any of the transformerless inverters to be able to start it, but I do think that the Victron has a pretty good chance of starting it up. So we'll see. Well, I think that's going to be enough tests. Let's get started with the Renogy. All right, the power cables are connected, so let's start it up. For the overload conditions, I'm starting with the water heater connected to this extension cord, which will pull 1870 watts as a base load. Then I'm adding additional loads with this hair blow dryer or this radiant heater or this light in order to push us to 110%, and then we'll do about 150%. I'll use this AC meter to see how long we're able to run, and then I have the Victron shunt that will tell us the DC total power draw. This AC meter can't do the total because with the water heater and everything, we'll be pushing near 3,000 watts and it can't handle that level. And then I'll track the voltage with the meter. I'll record that on this screen here. Here we go. Let's plug it in and see what it does. First thing is 110%. We'll use this hair blow dryer, which adds 365 watts to bring us to 2,235 watts. Let's see how long it runs. There we go. All right, we ran at about 2 seconds there. So, oh, kicked right back on and right back off. So I turned it off, but remember we still have the hot water heater on there. And there it is. Right back up. 2.2 kilowatts on the back side. So, man, that is a really fast recovery. As long as you turn the load off that overloaded it, it just kicked right back on. So I'm pretty happy with that. Let's see how long it'll last with the 150% overload. Swap the hair blow dryer with the 1,000-watt radiant heater. Okay, here goes the heater. That'll put us to 2,875 watts. Go. All right, that was about 1 second. So about 2 seconds that it came right back on again. And now we're pulling the hot water. All right, so that's pretty good. I mean, it held the 110% for a couple of seconds, and that was with a base load already on there for a while. And then 150% overload for about 1 second. What that tells us is it can take a pretty good spike, but it's not going to hold those higher outputs for very long. And the recovery was really quick. So now let's try all those giant induction loads and see how it does with those. All right, let's see what the Renogy can do with the pancake compressor. Nice. No problem. I'm pretty happy with that. Good job. All right, next. All right, it's time to try the 5 horsepower shop vac. Nice. I'm happy it's doing some of these. This is pretty good. All right, let's do the air conditioner. That's another real common one. This is a lot of work. Whew. If you appreciate all the effort I'm putting into this, give me a thumbs up and maybe consider subscribing. All right, air conditioner. Okay. Here's a problem. It's too cold in my shop for the AC to turn on. Did not anticipate that problem. I'll have to figure that out. All right, looks like the thermostat's right there, so I'll just use the hair blow dryer and warm it up a little. There it goes. Nice cold air, works no problem. A little bit of a crunchy noise when it started up, but it's only pulling 630 watts. You could run this thing for quite a while. All right, now we're getting to the big boy stuff. 6 horsepower compressor. All right, here we go. Big test. Nope. Was very unhappy about that. But turned right back on. Went into overload and protected itself and then came back on. I did not think it would be able to run this. You really need an inverter with a transformer for these really big induction loads, but you know, sometimes I'm surprised. Well, if it won't run this compressor, it won't run the dust collector, so we can stop there. The Renogy did pretty well. Let's go over all the details. It's time for the Renogy summary. This unit achieved 91.2% in our efficiency test, which is really pretty good. It ran for 15 minutes at 1.9 kilowatts with no issues. The infrared camera shows no problem hotspots, and I actually ran it for hours, 4 or 5 hours at a time at 1.5 kilowatts to do all of the testing on the LiTime battery that I've been using for this whole test setup, and I had no issues with it. It ran for 2 seconds at 110% and 1 second at 144%, easily protecting itself from overloads and then restarting within seconds. The Renogy has fairly quiet operation. Actually, it was the best of all the units I tested. When I ran the efficiency test at 1500 watts, the fans didn't even come on for 7 minutes. And even then, they started fairly quiet. Once they get ramped up, the sound level is only 44.2 decibels at 3 feet away. That's pretty good. I like things to run quiet if at all possible. And yeah, you don't want your electronics to get hot, but a system that can sense when it needs fans and not is appreciated. The output is a nice clean sine wave with good distribution at 60 Hertz, which you can see from the pink curve. It even has a good sine wave under load. This shows a comparison between the Renogy grid at my house and this modified sine wave inverter, which I use. It just clips onto my rigid batteries. And you can tell a dramatic difference between the output of this modified sine wave inverter and a pure sine wave inverter. And there's very little difference between the output of this pure sine wave inverter and the grid wave. So it's just a comparison for you to see how well it's performing. A pure sine wave inverter produces a smooth, continuous wave, similar to the electricity from the grid. In fact, in this case, very close. It's ideal for sensitive electronics and high-efficiency appliances. A microwave, for instance, has to have a pure sine wave inverter. If you run it on something else, it will do very terrible things. I've tried it. That's one of the reasons that I recommend, if you're going to get an inverter, get a pure sine wave inverter. They've come down so much in price, there's no reason to get a modified sine wave inverter. This inverter should have no problems with microwaves and sensitive equipment. This inverter will be able to run most household tools and appliances, but it is not powerful enough to run very large induction motors like the full-size compressor or a shop dust collector. Those large 1.5 horsepower motors are just too much for one of these inverters. It has 3 15 amp outlets and 1 2.1 amp USB-A port. It also has lugs, so you can hardwire your AC output instead of using plugs. I think that's pretty important if you want to integrate this system into an RV or a house. It comes with a remote on-off switch, but it does not come with a pre-wired pre-charge circuit, so you will need a pre-charge resistor or a pre-charge light bulb like the one I made here in order to connect your battery without having large discharges of energy when you connect the posts. Now, it does not accept AC input, so you can't use it as a UPS and you can't use it to charge a battery. Charge the battery, you would need a separate battery charger like this LiTime one I've been using to charge the battery for all this testing. It does come with 1-aught cables, so if you're never pulling more than 1,000 watts continuously, you could downsize the fuse on the battery and use these. However, I recommend using 2-aught cables for your 2,000 watt inverter. Then you don't have to worry about having loads that are too high for your cables and burning out your fuse or having very hot cables. So I would just go with the 2-aught. There's covers for the battery posts. I really like these connections. It has a good sized bolt. The bolt goes through the bus bar and it has a nut on the back side, so you can use that to connect maybe your battery monitor or something to the underside of the post as well, or lock the bolts on even better for vibrations if you're using this in some kind of vehicle. This is one of the ones I specifically bought so that you wouldn't have to have any doubts about whether I was giving you an honest review on it. And fortunately, for the most popular inverter on Amazon, it doesn't disappoint. The company history and the product popularity combined with today's performance numbers should give you reasonable confidence in purchasing this unit. I'll leave a link for this unit and all the others, as well as discounts that I can offer for a number of these inverters in the description below. But you can only put so much in the description, so go to my website, projectswithdave.com, where I will maintain more of an updated list of inverters and results that I've had, as well as discounts as they change over time. Now let's look at the MaxPart, the cheapest pure sine wave inverter that got substantial sales on Amazon. Let's see how it performs. This unit struggled with the endurance test, so I'm kind of curious to see how well it's going to do with overloading and large appliances. Since the output voltage under load is only 112.5 volts, the base load from the water heater is only going to pull 1.7 kilowatts. So I need a little bit larger load to get us to 110% or 2200 watts. Then I'll just add the hair blow dryer. I've made my connections with these finger tight posts, which I really don't like. I'll talk about that later. So before I switch it on, I need to get power to it from the main battery switch, and I'll use the pre-charge resistor to make sure the capacitors are charged first. Light comes on, light dims, turn the switch, we're good to go. And I like how that works. All right, now I can turn on the unit, and it's putting out 120 volts with no load. All right, let's connect the main water heater. Now I already know this can only run 8 minutes with the water heater, so we'll have to do this test quickly to see what the overload capacity is. Pulling 22 watts there at idle. Plug this guy in. Okay. Can hear it pulling right away. All right, now I can add the hair blow dryer. Now just adding the hair blow dryer will bring us to 2000 watts. I'm curious to see if it will even work with that. Let's see. Oh, it recovered quickly though. Well, I can't even do the 150% overload because it can't even do 2000 watts. All right, let's try our load, 110%. Ooh, 2 seconds. That was better than I thought. It didn't instantly die. This thing takes a long time to recover. Oh, shut up. All right. I mean, that's just all around disappointing performance. It can't even hold 2000 watts. It can't even deliver 2000 watts. Now, when I put the water heater on it, which should be a 2000 watt load, because the voltage is so low, it only puts out 1.7 kilowatts, and it can hold that, but only for 8 minutes. This is really disappointing. Well, I mean, let's see if there's any of these appliances that it can run. All right, let's try the shop vac. Well, that's good. It can run the shop vac. One of our smallest shop tool loads, the pancake compressor. Let's try it. Nice, it was actually able to do that one. All right, let's try the air conditioner. Don't have high hopes for this. No go. Well, I'm not surprised. That's pretty disappointing. I mean, it can't put out 2000 watts. You can't start an AC unit. There's no need to try the other larger equipment. So let's just go straight to the summary. This was the cheapest inverter. I guess you get what you pay for. It's really more like a 1500 watt inverter at best. This unit had one of the lowest efficiencies in the lineup at 85.3%. One of the methods manufacturers use to reduce the overall load seen by an inverter is to target the lower end of the 120 volts AC standard output. Since the voltage under load for this unit drops to 112.5 volts, the heating element was only actually pulling 1.7 kilowatts, and that's what allowed it to run for the endurance test. But even with that lower load, it only made it 8.5 minutes before it shut down. And then it would wait a minute, turn back on for a couple minutes, then shut off for a minute. It just couldn't even handle that load. As you saw in the test we just ran, it can't actually deliver 2000 watts. When I applied enough load to actually pull 2000 watts, the unit immediately shut down. It could not support 110% or 144% loads. Now, it didn't shut down immediately. It was still on for about 2 seconds, but it really wasn't delivering any power. You saw the voltage and everything immediately plummet as soon as those loads were applied. After overload, it takes about a minute to recover, so that's pretty slow. The infrared camera shows some hot spots during the endurance test. The cable connections tend to get hot because you can't properly torque the screws down with these plastic caps. The unit can handle about 3 minutes of load before the fans come on, which is good, but when they do come on, they are the loudest fans of any of the inverters I tested. These fans hit 58 decibels 3 feet away. Under load, it does produce a sine wave, but it isn't very clean, and you can see from the video how it kind of bounces around. For the most part, that's probably okay for the things you're going to be powering with it, but if you're trying to do something important that needs a clean input, I wouldn't use this one. The only large appliances it could run was the shop vac and the pancake compressor. It cannot power a window AC unit or large induction loads like the full-size compressor or the shop dust collector. No surprise there. Feels a little flimsy, and it's really light at only 2.6 pounds or 1.2 kilograms. It does have 3 USB-A ports and 1 USB-C port. I didn't test to see if they actually output the 2.4 amps that it claims, but I wouldn't bet on it. One unique feature is it does have a 12-volt car socket, so that's nice. I didn't test to see how much load you could put on it, but finally, you're connecting a 12-volt battery to it, so you should easily have 12 volts available. I don't know that that's super important. It does not have any lugs for hard wiring and AC output, so you can only take AC out from the plugs. It does come with a remote on-off switch, and it does not have a built-in pre-charge circuit, so you would need a pre-charge resistor or a little light bulb type circuit like I have for my setup. It does not accept AC as an input, so you can't use it as a UPS or charge batteries with it. It does come with some very thin, flimsy power cables that you can use for some other project. They are not any good for a 2000 watt inverter. I recommend using 2-aught cables for any 2000 watt inverter. Unless you know you're going to be pulling lower loads, and then you need to fuse your battery appropriately so you never overload the cables. The posts for connecting the cables are very short, and because of that, you can't even replace these useless knobs with a nut. There's just not enough threads there to work with. I mean, how much does it cost to put a little bit longer bolt? I mean, they've clearly done this to try and avoid the expense of putting a cover over it, but you still have the exposure of the edge of your cable. So it's just a terrible design. It does have fuses in the back, and it comes with some extras. In all of my overload testing, none of them failed, so I don't know under what circumstance you would need to replace them. It does have a small screen here that tells you the input DC voltage for reference. That's kind of nice. I can't imagine this review has convinced you to buy one of these units, but I'll leave links for all of the inverters in the description below, as well as any discounts I can offer. I'll also have a more detailed page on my website, projectswithdave.com, and I'll maintain that in a more updated fashion as things change over time. All right, it's time for the Giandel. Now, this one is often recommended by other YouTubers, so I'm really looking forward to putting it through its paces. And it certainly feels nice. I mean, it's pretty heavy duty, feels solid, has a really nice screen on it. Hopefully it performs as well as it looks. All right, I've connected the power cables. Now I just need to turn on the power, and I'll use my smart charging circuit. And I push the button and nothing happens. The light bulb doesn't light up because this system must have a built-in pre-charge circuit. Having a built-in pre-charge circuit is really nice. You don't have to worry about connecting your cables and using a pre-charge circuit before you turn the system on. So that's a really nice feature. So we can just go ahead and power it up. Has a nice screen here as well, showing the voltage of the battery coming in and the voltage and frequency and also power going out. That is a really nice screen, and I would like to be able to show them all at the same time. What I need is another camera. There we go. Right off, we can see the unit is drawing about 5 watts as an idle consumption. That's really good. So we're starting off well. Since this only has 2 outlets, I need to split this one. I'm starting with the water heater connected to this extension cord as the base load at 1.85 kilowatts. And then I'll add additional loads through my AC meter there. All right, here we go. Cranking away. First, I'll try adding the dryer to bring us to 110%. All right, let's try 110% overload with the dryer. Didn't shut off right away. 2080. It's not quite 110%, but it is over 2,000 watts. We're pulling 2.5 kilowatts from the battery, so it's a huge input. All right, that's clearly not going to do it. Let's, this will add 1,000 watts. Let's bump it up. Okay, back down 1740. Let's, woo! That stopped it in a hurry. Wow, booted right up after just a few seconds. All right, I'll add 1,000 watts to it just because I've done that with all the others. See how long it takes, and we're on. Yeah, about 1 second. About 10 seconds to restart. Well, it's the best one so far. All right, shop vac. I don't think this is gonna have a problem. Nice, no problem with shop vac. And compressor. No problem with that one. Time to bump it up a notch. Getting tired of moving this thing back and forth. Should have come up with a more creative solution. All right, let's try the AC unit. Plug that puppy in. We are blowing ice cold air. Started up, no problem. Well, 650 watts. Whew, that's cold. Okay, I'm cold enough. Power down. All right. Time for the big compressor. All right, this is a big ask. I don't expect it to be able to do that, but let's check and see. Well, it tried really hard, but it wasn't finally able to roll it over, and that's not surprising. You really need a transformer for that, but I thought I'd give it a shot. It tried harder than any of the other inverters so far, and then it came right back on once the overload, just a few seconds to recover. So, well, no need to try the dust collector. It won't be able to run that. Time for the Giandel summary. This unit achieved 89.2% in our efficiency test, which is at the higher end of the units I tested. It ran for 15 minutes at 1.9 kilowatts with no issues, and it ran for more than 2 minutes at the 110% loading, which was really closer to 105% due to the slight drop in voltage. Either way, it was over 2,000 watts, and it looked like it would run continuously that way. So I'd say that's pretty good. It ran for about 1 second at 144%, which is pretty standard, shutting down rapidly, protecting itself from overload, and then restarted in about 10 seconds. The fans come on pretty much right away under load, and they're about the middle of the pack for noise at 52.9 decibels from 3 feet away. As you can see here, the output is a nice clean sine wave with good distribution at 60 Hertz, even under load. It can run most household tools and appliances with no problems. It was also able to run the shop vac, the pancake compressor, and the window AC unit. However, just like the other transformerless inverters, it was not able to run the full-size compressor or the full-size dust collector. It feels very sturdy and weighs in at 11.7 pounds or 5.3 kilograms, which happens to be exactly the same weight as the Renogy. It has two 15 amp AC outlets and two USB-A ports. It also has lugs to hardwire your AC input in case you want to install this in an RV or a small cabin or something like that. It does come with a remote on-off switch, and this one is a little bit more unique. It has an indicator for fault, and it has a battery power level indicator, which is pretty nice. It does not accept AC input, so you cannot use it as a UPS or to charge your batteries. You'll need a separate charger for that. One unique feature is the built-in pre-charge circuit, so you don't need a separate pre-charge circuit like the one I have built here, and that's pretty nice. I don't like about this unit is the very small studs and nuts for the battery cable connection. It makes it difficult to get a solid connection with the lugs, and it can result in some higher temperatures under high loads, as you can see here in the infrared. I do really like the screen. It has all the information you need to understand the voltage on the input and the voltage and power on the output. It is a really nice screen, and it's the best of all the units that I've tested in this study. It does come with cables, but they're really insufficient for a 2,000 watt inverter. I would recommend that you use 2-aught cables for a 2 kilowatt inverter and a 250 amp fuse on the battery. So it also comes with a grounding cable, and I haven't mentioned it on the other inverters, but most of them do have a grounding lug. This unit has a decent reputation, and other than these weak lugs for the battery connection, I think you can have reasonable confidence in this unit. I'll leave links for this and all the other inverters, as well as any discounts I can offer you in the description below. You can only put so much in the description, so I also have more details on my website, projectswithdave.com, so be sure and check it out there. Okay, I have the 2000 watt LiTime cables connected. Now let's turn it on. Pre-charge and powered up. All right, this one has a display, so I'll try and capture that up here as well. And it does alternate between battery voltage and line voltage, so that's pretty convenient. And then it shows watts at the bottom. No load on the inverter. It's putting out 112 volts and pulling 6 watts at idle. That's really efficient. 6 watts is one of the best. I really like that. The LiTime also targets the lower end of the voltage range, actually just under it at 109.8 volts AC. Since the output voltage under load is only 109.8 volts, the base load from the water heater is only 1.6 kilowatts. So I'm going to add the dryer on load to confirm that we can actually achieve the 1.84 kilowatt load that all the others achieved for the endurance test. So first I can plug in the water heater, and that gets us up to 1500 watts, and then I'll put the dryer on low. Let's hope, hopefully it can do that. Let's see what we get here. There we go. So that's good. It has no issues hitting the endurance load. The fans haven't even come on yet. So now to hit 110%, I need to reconfigure things a little bit. I'll use the radiant heater plus the hair blow dryer, and that'll give me about 2.2 kilowatts. So let's try that. All right, so radiant heater on gives us 886 watts. Then I'll add this heater. Hey, that was pretty good. I trimmed a bunch of that out because I ran it for about 2 minutes and it had no issues. So at least they're not lying about the output performance. It can put out over 2000 watts continuously. And the one thing to consider there is the voltage was dropping down to about 105, 106 volts. So if you need a higher voltage for something, you would need to consider that, although most things I don't think that's going to be a problem for. All right, let's try the overload. For overload, I'm going to do the water heater and this guy on high. Now this should shut down pretty much immediately. Let's give it a shot. 145% overload. Wow, that was pretty cool. I mean, it shut down and immediately turned back on. Let's try that again. It didn't shut down. There it goes. Well, that's an interesting result. Okay, so it didn't shut down for quite a while. I'll have to go back and look at the footage. I'll put it up on the screen here, but that was quite a few seconds. It just continued to run, but it wasn't putting out over 2000 watts. You can see the output wattage was around 1500 watts. It just dropped the voltage, which might not be ideal for some things. But as soon as I turned the load off a couple seconds later, it powered back up. So, I mean, it's a real trooper. It does everything it can to stay on, rather than just immediately cutting power when it's overloaded. I don't know if that's good or bad. I mean, I have to give it to it. I mean, it puts a strong effort into staying on. Well, it is performing better than I anticipated. Usually when inverters are putting out less than 110 volts, they're compromising a lot of other things, but it seems like they've just strategically done that to make it so that it will run more things with the same size inverter. The output specs are still achieving 2000 watts, no problem, and even above that. So let's see with the large induction loads how well it does with those. All right, I'm going to do 2 of these back to back because I don't think it's going to have a problem. The first one is the shop vac. Okay, that was good. It made a little beep there on the surge load, probably dropped the voltage down to compensate, but it ran it no problem. Let's try the compressor. Also no problem. I bet you it's going to run the AC unit. Let's give that a shot, and then we'll jump up to the big boys. Okay, it's time to run the AC. All right. There was a beep to let you know that it had hit overload, but that was just the startup load. and dropped the voltage a little bit, but started it right up. No problem. Window AC unit, good to go. And that is cold. I gotta shut that down. All right, massive induction load time. I don't expect this to work, but we gotta try it. Ready? That inverter will not give up. Okay, well, I mean, it was running it. The motor was turning over. You could hear the compressor pumping, but it would not be good for the motor to continue to run in that condition. And maybe that's one of the risks of the inverter not shutting down when it hits really high overloads. It just cuts the voltage and continues to try. So I guess that's a really important thing to understand about it. In some cases, that's great. You know, you don't have something shut off accidentally. You know, your lights are going to dim a little, but things will keep going. But in a situation like this, you would want it to shut off. You wouldn't want your compressor to be trying to start like that. That's not good for it. But that being said, that's the most effort any of these inverters have put into starting something. So you got to give it some credit for that. I'm kind of curious to see what it'll do with the dust collector. So I guess I have to try that next. All right, let's see what happens. Come on. Oh. Okay, that's enough. Stop. It almost did it. I mean, it was starting to spin up, but it just didn't quite have the ump. And then it did shut down, but immediately started back up and it was just trying over and over again. Okay, so I didn't want it to do that to my dust collector. But man, I mean, you got to give it credit. And the fans aren't even running, so it's not like anything's getting super hot. It's just putting its very best effort into starting things. And I guess that's a strategy. You know, it starts with a fairly low voltage, and then it cuts it down pretty far when things are overloaded. If it were starting at a higher voltage and cutting back a little bit, maybe it would do a little better. But it's still, I mean, I got to give it credit. It's done more to try and start these large pieces of equipment than any of the other inverters so far. So that's something. This LiTime inverter packs a punch for being one of the cheapest inverters on the lineup. It has no frills except for a very nice little screen. This unit actually had the highest efficiency in the lineup at 91.3%, but it also had the lowest voltage under load at 109.8 volts. Because of the lower voltage, I had to add additional resistance loads to kick it up to the 110% overload condition, but it was able to maintain that really well. I ran it for over 2 minutes. It appeared to be able to run it pretty much continuously. So it is a true 2000 watt output inverter. It even tried to support the 144% load, although if you look at the numbers, it was really only putting out 1500 watts because it cut the voltage all the way down to 80 volts in order to achieve that. And it tried to run it for about 15 seconds, so it's a real trooper. But that may not be good for your equipment if it's trying to run things at that low of a voltage. So that's something to consider. You know, if you're running sensitive equipment, you may not want it to be running at that low of a voltage. Taking a look with the infrared camera, there's no big concern areas with the endurance test. You can see the typical warm spots around the mounts, but nothing to be concerned about. The cooling fans had the biggest delay of all the inverters, running for 9 minutes under load without powering them on. However, when they do finally come on, they're at the louder end of all the units tested at 55.4 dB from 3 feet away. Under load, the sine wave gets a little bit jittery, but it's still pretty clean, so no concerns with the sine wave output. It ran the shop vac, the pancake compressor, and the window air conditioner with no issues. Although it made a valiant effort, it cannot power large induction loads like the full-size compressor or the shop dust collector. It has a sleek and very sturdy design, weighing in at 7.5 pounds or 3.4 kg. It has two 15 amp outlets and no USB-A or C ports. It does not have any lugs to hardwire your AC output, so you have to use the plugs for everything that you want to power. It also does not have any pre-charge circuits built in, so you would need a pre-charge resistor or a little circuit like I use to get everything connected before you turn the power on. It doesn't accept any AC input, so you can't use it as a UPS and you can't use it to charge your battery. It does come with cables. It's made of 4 strands of 8-gauge cable, which is a perfectly acceptable way to build them. And you can see using this online calculator, it's the equivalent of a 2-gauge single wire. And that might be enough if you're running relatively small loads. But if you plan to max it out all the time, I would recommend 2-aught cables, which would really be 8 8-gauge wires bundled together if you were going to go this way. The posts for connecting the battery cables are robust, and they are a little close together. If you have very large lugs like I do and you tilt them down towards each other, it's possible to contact them, so that's something to be careful of. And it comes with little covers for those cables so that you don't accidentally touch them. If you're interested in purchasing this unit, I'll leave links for this and all the inverters, as well as any discounts I can offer in the description below. And I'll also have more details on these inverters, and I'll make updates as changes come along on my website, projectswithdave.com. Next up, the BougeRV 2000 watt pure sine wave inverter. And I have tested a lot of BougeRV equipment and I have never been disappointed, so I'm looking forward to seeing how well this one does. Feels heavy. Could be good. All right, power cables are connected, so let's start it up. It has this really nice little screen, which is great. It's remote. I can put it here with all the other devices I'm trying to monitor, and I only need one camera to do it. It even has temperature on there. Look at that, 1 degree Celsius. That tells you something about my shop. This BougeRV inverter is the only one of the transformerless inverters in the lineup that has the ability to switch between 110 and 120 volt outputs. And it's right here on the screen. I can just press this button and it'll shut down and restart at the other voltage. So I'm going to be doing all the testing on the 120 volt setting. And at 120 volts, it maintains 118.6 volts under load or thereabouts. So that is a fantastic option. If I were running power tools, I would want to run them at the higher voltage. But if I was just running a little resistance heater to keep me warm, maybe I want to save some battery power, I could drop it down to the lower voltage and that will automatically reduce the amount of power that's being consumed. That's a really nice feature. I really like it. So now I'm going to use the water heater plus the hair blow dryer to confirm the 110% performance. And then I'll add the radiant heater to boost it to about 144%. All right, we'll plug in the water heater. Boom. You can hear those fans, they kick on right away. Yeah, about 1.8 kilowatts. All right, I've added the Victron shunt on the screen. Let's try the hair blow dryer, 110%. Ooh, that's pretty good. Just under 110%, but it is traipsing right along. I'll let it run for a minute and cut it out and come back when it's been going for 2 minutes or so, and we'll make sure that it's not going to die on us. But I'm guessing it'll run continuously at this load. Hey, there it goes. It's getting upset. It's giving me a warning. Hey there, finally shut down. See how long it takes to boot back up. Wow, just a few seconds to boot back up and away we go again. Man, I am happy with that. I'll put up on the screen how many minutes that ran at almost 110% overload. All right, let's add the radiant heater and see what it does at 144, 145%. Water heater plus radiant heater. Here we go. Wow, that was right back. It actually supported that load for a second. I'll have to go back and look at the footage and see what the voltage dropped to. I'll put it up on the screen. That is really good. I'm really impressed with this thing. Let's try some of the large equipment and see what it can do. All right, here we go. I'm going to do the shop vac and the compressor back to back again. I think it's going to run them both, so this should be quick. Shop vac. Fans kicked on right away, but no problem running it. Now for the compressor. Once again, no problem. Shop vac, compressor. The way it was running before, I knew it wasn't going to be a problem. I'm sure it's going to do just fine with the AC, so let's do that real quick, and then we'll try the bigger equipment. All right, AC unit's plugged in. Let's give it a shot. That was smooth. That is blowing some cold air. I could just tell that it wasn't going to have any problems. This thing is a trooper. I like this inverter. Well, let's roll in the big guns. All right, full size compressor. Let's do it. Well, it was trying. Honestly, I wish it wouldn't try so hard because that's not good for the motor, but boy, it put a solid effort in. It didn't just cut out. So, I mean, it tries hard. Yeah, I'm kind of curious with the big dust collector if it'll do the same thing that the LiTime inverter did and try and spool it up. I guess I'll try it. All right, full-size shop dust collector. Let's see what it does. Okay. All right, I had to shut the inverter off and turn it back on again. It didn't want to restart after that. And even though the bag blew up, it wasn't actually running. You could tell the voltage was really low. So it was running it at a really low RPM, kind of. So it made a really valiant effort, but it wasn't going to run this thing. That being said, of the transformer-less inverters, this one definitely made the best attempt at it. The LiTime one gave it a shot, but not quite as close as this one. So I would give this one the clear winner with the large induction motors. Can't actually run them, but comes really close. Time for the summary. I am really impressed with this BougeRV inverter. It has exceeded my expectations. This unit has decent efficiency at 89.4%. Its output voltage under load was one of the highest at 118.6 volts. And it has the flexibility to run down at the 110 volt range or the 120 volt range, and that's pretty neat. I was able to run it at 110% load for 1 minute and 32 seconds, and it even gave a warning before it shut down. It even supported the 144 volt load for a full 5 seconds, and that is pretty impressive performance. After overload, it recovers almost immediately. The infrared camera showed no big concern areas during the endurance test, even when looking around the cable connection points and up inside the fan area. The cooling fans on this unit come on right away if the load is more than 50%, which it was under the testing that I did. They are at the louder end at 55.8 dB at 3 feet away. The sine wave looks very clean, showing only slight deviation under load. It ran the shop vac, the pancake compressor, and the window AC unit with no issues. Although it made a valiant effort, it cannot power large induction tools like the full-size compressor or the shop dust collector. It's a robust, compact package weighing in at 8.3 pounds or 3.8 kilograms. It has one 20 amp outlet and one 50 amp outlet. There is one 3 amp USB-A port, but no USB-C ports. It does have lugs to hardwire your AC input for your cabin or RV. It not only has a remote on-off switch, but a fantastic integrated screen displaying AC and DC voltage as well as power output and temperature. It also has an app for controlling and monitoring the unit through Bluetooth, although you do have to create an account to use it. It does not have a pre-charge circuit, so you'll need a pre-charge resistor or a little light bulb circuit like the one I have here in order to connect your cables without any big arcs. It does not accept an AC input, so you can't use it as a UPS or use it to charge your battery. It does not come with battery cables, which is fine. I'd rather get my own. If you plan to max it out, I would recommend getting 2-aught cables. The posts for connecting the battery cables are robust and plenty far apart. It also comes with covers and a mostly useless 3-inch grounding wire. If you're interested in purchasing this unit, I'll leave links for this and all the other inverters, as well as any discounts I can offer in the description below. The discounts for this inverter are pretty significant, but they're short-lived, so you have to act quickly if you want to purchase this one. I also have more details and updates on my website, projectswithdave.com. Now we're moving into the industrial beasts of this analysis. This 2000-watt Sungold power inverter is the first one with an actual transformer, and it is heavy. I expect it to do better with the induction loads. So let's see. There was a little bit of setup I had to do with the dip switches and things to configure it for the way we're operating it today, but that's going to be different depending on your situation, so we're not going to go over those details today. It does have both a built-in display and a remote display, so I'm going to be able to display all of the parameters while we're doing the operation. All right, let's start it up. Big capacitors. Welcome. Ooh, 121 volts. Overachiever. Well, the details on that display are very small, so it might be a little hard for you to see on the screen. I'll blow it up as much as I can. All right, this inverter has a plenty high voltage, so we can have a base load of the water heater. Fans come on right away because that's more than a 50% load. All right, let's add the hair blower dryer, 110%. Okay, it says it's doing 114% load. I know from the instruction manual it's supposed to be able to do this load for like 15 minutes, so I'm not going to run it that long. We'll run it here for several minutes just to make sure there's no issues, but it's going to do it for a long time. All right, no problems at 114%. All right, I've added the 1000-watt heater. Ready and on. It's very unhappy. It says 126% load. Still holding the voltage at 109 volts. Now this is meeting my expectations. Man, look at that. On the DC side, we're pulling 276 amps. And the battery's doing fine. That's why I wanted the big battery. It's alarming to let you know that it's in overload. All right. It finally shut off. I guess it doesn't auto recover from that. So I shut off the medium radiant heater and we're just using the water heater, and it kicked right back on. But I had to turn it off and back on again. It didn't auto start from that severe overload condition. But man, that ran a long time. I'll put the numbers up on the screen. That's pretty impressive. I have high hopes for this thing. Well, let's run the simple tools and then we'll bump it up. We'll do them as fast as possible here. All right, let's do these back to back. Might even try them together. Huh? Vacuum. Compressor. Compressor and vacuum. And that's the power of a transformer. Man, that is a beast. All right. I have hope that this is going to run the big compressor. But first we have to do the AC unit, even though we'll have no problem. And then we'll do the other ones. All right, real quick AC unit test. No problem. No problem. It's blowing ice cold air. Give a little beep there because there was an overload at startup, just like there would be. It says it's running at 34% load. Everything's happy. Time to try the big induction loads. All right, I've been waiting for this moment, and I'm going to be disappointed if it can't do it. Ready? Come on, come on, come on, come on. No. Oh. I'm so sad. I thought I would be able to do it. I don't have super high hopes for this because usually if you can't do the compressor, you can't do this guy, but let's try it. Unfortunately, it can't run the big induction loads either, so I guess we would need the 3000 watt inverter. I'm pretty confident the 3000 watt inverter could do it, but I don't have that to check. So we still have the Victron to try. If it can't do it, then there's not a 2000 watt inverter that can do it. And actually that's a 3 kVA, 2400 watt continuous, so it's not exactly 2000 watt. We'll see. All right, time for the summary. This Sungold power inverter is a heavy-duty machine that is really in a different category than the transformerless inverters, and its price reflects that. This unit had the lowest efficiency of all the inverters I tested at 84%, and that's pretty much due to the transformer itself. Its output voltage under load was one of the best at 118.5 volts AC. It has both the best and the worst idle consumption. If you put it in power save off mode, it consumes 38 watts. And if you put it in power save on mode or standby mode, it consumes only 2 watts. That's a great option if you have an intermittent load. Nothing I've seen can beat a 2-watt idle consumption. It was able to run at 110% load for over 2 minutes and probably would have done it continuously. It supported 144% load for a full 63 seconds. Very impressive performance. After the high capacity overload, I had to turn it off and back on again to get it to recover. The infrared camera shows no big concern areas during the endurance test. The cooling fans come on right away under loads over 50%, and they're at the middle of the pack at 48.5 dBs from 3 feet away. Under load, the sine wave looks very clean, but it does squish a little bit. It not only ran the shop vac and the pancake compressor, but was able to run them both at the same time. I was able to start up one while the other one was already running, which puts it in overload, and it ran them no problem. It ran the window AC unit with no issues, which I fully expected it to do. Although it made a valiant effort, it was not able to start the large power induction loads like the full-size compressor or the shop dust collector. I was kind of hoping it would be able to do that. You probably need the 3000 watt version in order to run some of those bigger loads. It is a very robust beast, weighing in at 42.3 pounds. It has a double gang 20 amp GFCI outlet mounted in the front. There are no USB-C or USB-A ports. It does have lugs to wire both an AC input and an AC output for your RV or cabin. And you could even use your generator as one of those AC inputs because it has the ability to turn on and off a generator. Not only does it have an integrated screen with LED indicators, but it has a very elaborate remote screen with power on-off switch built into it. And there's a lot of detailed information available on that screen. It even includes a temperature sensor that you can connect to your batteries to make sure that the system shuts off if there's a problem. And you really need that when you're using it in charging mode. It does not have wireless control or a built-in pre-charge circuit, so you probably want some kind of pre-charge system when you connect up your battery cable. Because it has AC input, you can use this as a UPS, and you can use it to charge a variety of batteries, including lead acid and lithium iron phosphate. It does not come with battery cables, but you can order them from Sungold Power. Either way, I would recommend using 2-watt cables. There were times we were pulling over 300 amps, so you want to have good cables. The posts for connecting the battery cables are robust and plenty far apart, with plenty of stud for making your connection. There are very nice robust covers included. They actually mount with screws over the terminals, and a lot of the covers that the other inverters have crack when I try and take them on and off, especially in my cold shop. These ones probably not going to have that problem. I don't have time to cover all the details of all the things this inverter can do, but it's probably not going to disappoint you. If you're interested in purchasing this unit or any of the inverters covered today, I'll have links for this and all the inverters as well as any discounts I can offer in the description below. I'll also include more details and information with updates on my website, projectswithdave.com. All right, on to Victron, the last one in the lineup. This Victron 3 kVA inverter is the most powerful in the lineup and the most expensive. I'd like to thank my friend Ed at Off Grid Power Systems, a local off-grid solar installer, for letting me borrow this training inverter. If you're looking for an off-grid installer in the Ohio area, you can find his website link in the description below. This inverter is a bit higher spec than the rest, with a continuous output rating of 2400 watts. This unit, and all Victron units to my knowledge, have a toroidal transformer in it, and that allows them to achieve higher efficiencies. It is also the heaviest. Some configuration is required and can usually be done by whoever is selling the equipment to you. I've already done it off screen, but if you want to see how it's done, I have a whole video where I install a Victron system. It's 48 volt, but the setup is basically the same. And I'll link to that in the description below as well. All right, I have my outlet connected to AC1 out, and then I have an Ethernet cable connected to the computer port. The 2-watt battery cables are connected to the battery, negative and minus, and there are 2 bolts, so you can use smaller cables and double them up very easily. All right, it's all wired up. Now we can turn it on. Cables are connected, so now I can send power to the unit. They're big capacitors. It takes a long time to charge them. Probably good enough. There we go. There we go. Powered up. 119.6 volts. And you can see the idle consumption at 31 watts, which is pretty interesting. My multi-plus idle consumption is only 9 or 10 watts. I'm not sure why this one is so much more. This unit is designed for hardwire installation, so I've added a 20 amp outlet for our test purposes. And I can monitor everything using the computer and integrated software. You can get a display for this if you want to, and a little touch screen show you everything it's doing. You can control it all from there, but that's a separate purchase. All right, I can plug in my base load of the water heater. We're pulling 1763 watts. All right, now I can add the hair blow dryer. We'll put it to the 110% load. The reality is that's going to be no problem because this can run 2400 watts continuously. So let's bump it up a bit. I'll put it on high. That was enough to stop it. Well, I got carried away with that. It ran it for a minute, but that wasn't part of my test. So let me just stick to the plan and put the radiant heater on so I can match the performance with all of the others. We'll do the water heater and the radiant heater. All right, here we go. 144, 145% overload. See how long it can run. Overload. Yeah, I see that thing. There we go. 2700 watts. Woohoo! It's like 350 amps. Ooh. The battery disconnected. I found the limit of the battery. All right, well, that's an interesting dilemma. Okay, to fix that, I'm going to feed in some additional 12 volt power from AC. So I'll be like charging the battery and running this at the same time. Because we tripped the BMS on the battery. I'll have to go back and look at the video. It was probably more than 350 amps continuous. Yeah, I can only put out 3200 watts. All right, you can see I'm pushing almost 500 watts back into the battery right now through the battery charging connector I have here. Hopefully that gives us enough of an edge to actually let this thing run a little bit longer. The water heater back on. Okay. I might blow my fuse, which would be super annoying because I only have one. There it goes. Overload. Yeah, thank you. Go away. There we are. Yeah, over 3000 watts from the battery plus the 500 watts from the charger getting fed into the unit. And it's pulling 2700 watts. And it doesn't seem to care. I did get the alarm warning. I'm going to see how long that can run. It's apparently a long time. This thing's on a different level. Yeah, you can see it there, 2736 watts. It's giving that battery a run for its money too, right at the edge of its limit, 3000 watts continuous. That battery is pretty amazing. On the inverter itself, the little overload light is blinking. So, I mean, it is in overload. It just doesn't want to give up. All right, I'm going to drain my battery before this thing quits. So I'm going to stop there. But, man, that's pretty impressive. Go ahead and shut that one off. All right, time for the AC test. I don't think this will be any problem. Here we go. Started right up. Woo, that's blowing some cold air. All right, as expected, it had no problem starting and running that. It did get this little battery voltage ripple error, which I don't think is unexpected. We're starting up a pretty difficult motor to get running, and that's going to cause some disturbance in the electrical pathways. All right, it is time for all the other induction loads. All right, let's try the shop vac. Then I'll immediately do the compressor, and if they both work, I will turn one of them off and turn the other one back on and see if they'll run both at the same time. All right, here we go. Shop vac. Nice. Well, it worked. And that was a good load. And I'll have all the numbers up there so you can see how much current and everything's pulling. But that's quite a substantial load. Fans kicked on, they just kicked back off. But the battery was able to support that. This LiTime battery is amazing. And we could run both. Now, the Sungold Power was able to run both, which was pretty good. Let's see if this one can set itself apart by actually running the compressor and dust collector. That will be the big benchmark. All right, time for the big test, the full-size compressor. Let's see what happens. Come on. No. Guess it's not going to do it. Bummer. One reason I thought this would work is I have a 3 kVA 48 volt Victron inverter, and it starts this compressor no problem. And I really think it has to do with the incoming voltage being so low. It's just another reason why 12 volt systems are not a great choice. If it's at all possible, you should make a 48 volt system. All right, one last piece of equipment to try, the dust collector. Here we go. All right, it ran it. Actually, it started up pretty easily. And maybe if I charge this battery all the way up and we had, you know, the highest voltage coming in, we might have had a chance to start the compressor. But I think the reality is you need 48 volt systems when you're running really big equipment. And 2,000 watt inverters, this one's 2,400 watt, but you know, anything less than 3,000 watts, you're not really running big equipment. It just is a tool to show you where the limits are for each one of these inverters. To test my theory, if a little bit more stable input voltage would push us over the threshold, I have used both inputs on the Multi-Plus to connect an additional battery, and we'll see if that's enough. I mean, it was so close. Let's see what happened. All right, here we go, attempt number 3. There we go. So, I mean, that should just highlight for you right there why 12 volt systems are such a challenge. I mean, just losing 1 volt, you lose nearly 10% of your input power, and that's a tremendous loss. You're pulling almost 400 amps through these cables, which is also a huge loss. 48 volt systems are just hands down way better. But that also proves my point that it's not the inverter so much. My 48 volt Multi-Plus started this no problem with any 48 volt battery. And this one can do it, but boy, you have to have a very stable, heavy duty 12 volt input to achieve it. So yeah, go 48 volt if you can. Wow, okay, time for a summary for the Victron. Victron makes industrial inverters, and this is a quality machine. It's in a category all by itself. It is quite expensive, but you can expect it to last and not give you any problems. This unit had an average efficiency of 87%. Its output voltage under load was very good at 117.7 volts. The full-on idle consumption wasn't great at 31 watts, but it has 2 AES low-power modes to reduce that. And depending on which mode you choose, it can drop it to as little as 8 watts. The sine wave version draws 23 watts and holds about 74 volts AC online, powering loads pretty much immediately. The search mode uses only 8 watts, but takes a few milliseconds to power up when it sees a load. As I mentioned before, my Victron 48 volt Multi-Plus has an always-on idle consumption of only 10 watts. And this unit I borrowed is a little bit older model. The newer ones actually have a much better performance in the idle consumption space. I was able to run it at 110% load for over 2 minutes, and it probably would have gone on indefinitely since that load is below its rated continuous capacity. It supported the higher load of 2731 watts for over 4 minutes before I stopped the test, and that was very impressive. It would have gone on for some time, but I didn't want to take the time to see what the final limit would be. It was showing an overload, so I'm sure at some point it would have cut out. The infrared camera showed no big concern areas during the endurance test. The cooling fans come on right away under loads more than 50%, which all the loads I tested were more than 50%. And they're in the middle of the pack for noise at 49.1 dB at 3 feet away. Under load, the sine wave looks very clean for this unit. It not only ran the shop vac and the pancake compressor, but ran them both at the same time with no issues. It ran the window AC unit with no problems, and it was able to run the dust collector on one battery. But I had to add another battery to run the full-size air compressor. The input voltage drop improvement was only 1.3 volts with the extra battery, but that was enough to allow it to power the system. When you start with only 12 volts, there isn't a lot of room to work with. My 48 volt 3 kVA Multiplus can start it no problem with even a very small 48 volt battery. Always go 48 volts if at all possible. It's solidly built, weighing in at 45.5 pounds or 20.6 kg, and it's designed to be hardwired, so it doesn't have any outlets or USB ports. It has lugs to hardwire both AC input and 2 separate AC outputs for pass-through and critical loads. It not only has integrated indicator lights so you can see on the unit what the performance is, but you can also get an external control panel with a touchscreen and wireless management if you want to have full control outside of the unit. However, that control panel is something you have to purchase separately. If you operate it off-grid, you would want a pre-charge circuit for the very large capacitors in this system. However, I know my 48 volt Multiplus will pre-charge the capacitors if you connect it to grid first. I presume this one's the same, but I didn't check it. It does have an AC input and is designed to operate as a UPS. It has its own built-in transfer switch and its own built-in ground neutral bond. It's able to use the AC input to charge a wide variety of batteries, including lead acid and lithium iron phosphate. That AC input can also be a generator, and it has the ability to control that generator to turn it on and off. It doesn't come with battery cables, and for this unit you need 4-aught cables and a 400 amp fuse. This 300 amp battery that I've used for the entire test is a little bit under spec for this inverter. Starting the compressor required a 370 amp DC surge, and that's too much for just one battery. There are 2 posts for the positive and 2 posts for the negative, so you can connect 2 sets of battery cables, allowing you to use a smaller cable to get more current capacity if you don't have 4-aught cables. If you are interested in purchasing this unit, I'll leave links for this and all the other inverters I have, as well as any discounts I can offer, in the description below. I also will have more details on my website, projectswithdave.com. Now let's take a quick look at how the LiTime 250 amp hour battery performed over this entire test, and then we'll do an overall comparison including price of all the units. This battery LiTime sent me turned out to be a great match for this project. We pushed it to its limits and beyond. At one point with the Victron inverter, I was pulling over 4,000 watts and over 350 amps for 10 seconds before the BMS cut the power. The Victron inverter was the only one that could push it past its limits. If you have to go 12 volts, this is a great way to get a substantial amount of capacity and power delivery without spending the money on expensive cables to combine multiple batteries together. However, if you're going with a higher power inverter like the Sungold Power or the Victron and plan to push them to the limit, you would need more than just one battery. I did run multiple capacity tests in addition to all the surge load abuse that we gave it. I even accidentally shorted it out once, and it protected itself and restarted with no issues. The rated capacity is 560 amp hours, and I was able to get 577.8 amp hours in my capacity test, which is 103% of its rated capacity. So I'm pretty confident the batteries inside are high quality batteries. The only issue I had was the caps to cover the post got broken in shipping. It's currently on sale, and with my discount code in the description, you can get an additional 8% off. So it's a good time to get it if this is what you're looking for. All right, I made a matrix of some of the key metrics and sorted it by the current listed pricing. And the prices do fluctuate around a bit, but this is pretty much the typical stagger that you're going to see for each one of these units. Under a good sale, you might find one cheaper than another, but this is the basic order. Then I added some color coding to make it easier to digest visually. The green means it's one of the best, yellow means somewhere in the middle, and red means it doesn't have that feature or capability or it's really bad. So the cheapest one on the list was the MaxPart at $170. It turns out to be a complete fraud. It's not even able to deliver 2,000 watts. It even sounds like there's loose parts inside. I will leave a link in the description for your reference, but you'd be better off buying a decent brand 1500 watt inverter than this pretend 2000 watt inverter. I'm afraid this one belongs in the garbage. I wasted some money, so you wouldn't have to. The LiTime comes in at $180, but with my 8% discount, you might actually even be able to get this cheaper than the MaxPart. And it can actually deliver 2000 watts. Other than the voltage being on the low end and the fans being a bit noisy, it's a low-cost, no-frills inverter that delivers as advertised. It even has the best efficiency of all the inverters I tested, and it boasts one of the lowest idle losses at 5.5 watts. Not a bad deal. The $210 BougeRV turns out to be one of the best values. It's priced at the lower end of the bunch, but it has the features of some of the higher-end inverters. And it has a really nice screen, plus a Bluetooth connection. It has decent efficiency, selectable AC output voltage, and a pretty decent idle loss at 7 watts. I expected this unit to do well, and I was not disappointed. For a limited time, BougeRV is offering my viewers a 40% discount if you use the code in the description below. And that's going to be hard to beat. So if you want this inverter, don't wait. Moving up in price a little bit, the Giandel at $260. You get a decent inverter with a really nice built-in screen. It has a decent efficiency and boasts the best standard idle loss at 5 watts. It was a trooper, delivering full power even in overload conditions. It was also the only transformerless inverter with a built-in pre-charge circuit, and that's really pretty nice. My only complaint with this inverter was the really small lugs for the battery connections. So if you get this inverter, just pay very close attention to getting these tightened down properly and make sure you have a really good connection so they don't get too hot. Then for just $7 more at $267, you can get the most popular inverter on Amazon, the 2000 watt Renogy. It was basically tied for the best efficiency and it had a decent idle loss at 10 watts. It has the quietest fans, something that happens to be important to me. It meets all the rated specs and quickly shuts down if you exceed them. There are a lot of options in the Renogy lineup to add to this unit, and I'm sure if you wanted to sell it at some point and upgrade, you'd be able to get a decent price for it. Discounts for this one fluctuate, so I'll do what I can in the description. Now for a big jump in price, the Sungold power inverter, which comes in at $699. But this is a different beast. It's an industrial level unit with a built-in transformer. It has the significant additional capability of being used as a UPS and to charge batteries, eliminating the need to buy a separate battery charger, as well as all the wiring that would be required to add that additional unit. It gives you much more insulation to resistive loads, especially loads with induction motors. If you plan to run a lot of power tools, you probably want a unit that has a transformer in it. The transformer does cost you some on the efficiency side, but if you have an intermittent load, you can probably make that up with the impressive 2 watt standby efficiency idle loss. If you have to run it in always active mode though, the idle loss is a pretty good hit. It comes with a battery temperature sensor and one of the nicest screens of all the units. It has a great reputation for reliability. You probably won't be disappointed with this unit's performance. Finally, with a huge jump in price and capability, the Victron is the gold standard for reliability. It's designed to be a permanent install and it's more powerful than the rest of these units. It's a 3 kVA inverter and it's rated to deliver a continuous 2400 watt. It was the only one that could run the large compressor and the dust collector. Even with its transformer, it had a decent efficiency because of its toroidal transformers. It can be combined with additional units to deliver more power or a split phase output. With an optional screen, you can manage more features and capability than we could possibly cover in this video. That being said, if you're considering this level of performance, you really should go with a 48 volt system unless you absolutely have to have 12 volts. There's a lot of options when purchasing Victron. Current Connected, for instance, will pre-program the units for you, and they'll double the warranty that the manufacturer delivers. Signature Solar will give you an additional discount when you use the link that I have for you in the description below. I've been running Victron equipment for several years and I have never had any issues. I will have a much better breakdown for all the deals and options for you on my website, projectswithdave.com. I have a lot of parts left over from making my little pre-charge resistor circuit with the light bulb indicator. I've considered making those available on my website. Let me know in the comments below if you're interested in that. If there's enough interest, maybe I'll put some kits together and you can purchase them off the website until the parts run out. Now that I've gone through all these 12-volt inverters, watch this video on why you should not do a 12-volt system. I have finally found a source for EVE lithium iron phosphate cells that exceed the rated capacity in my testing, and I can get them for you at a great discount. I'll link that in the description below. I'm working on a simple 12-volt DIY battery, and I'll post it here when I'm finished. Thanks for watching, and I'll see you next time.